But Einstein's equations actually allow gravity to also be repulsive. It can push outward as opposed to just pulling inward. And this is something that we have never experienced because the gravity created by a rocky object like the Earth is always the attractive variety. The gravity created by the sun, again, a compact object, is always the attractive variety. But Einstein's math shows that if you don't have a rocky object that's isolated in space, but rather energy that is uniformly spread through a region of space, that kind of entity yields repulsive gravity. Why is that important to your question? If the very early universe, that little tiny head of a pin that you're talking about, if it was filled with a uniform bath of this energy, we call it the inflaton field. The name doesn't matter. But if it was filled with that energy, it would have been subject to repulsive gravity. What does repulsive gravity do? Pushes everything apart, causes everything to rush outward. So the bang of the Big Bang may have been a spark of repulsive gravity operating with a tiny region of space that pushed everything apart.
And this concept of repulsive gravity is just theoretical? Have we observed any sort of element in the universe that...
It is theoretical, but it's at a level of understanding that I think most physicists would say causes it to migrate into the camp of established understanding of how gravity works.